Hello, everyone. Welcome to our webinar. We're going to allow some time for folks to come into the virtual space. You can utilize the chat feature. Let us know where you are tuning in from today. Thank you for starting us off, Maggie. Fantastic. Oh, they're coming in. North Carolina, Jacksonville Beach, Michigan, New Hampshire, New York. I now can no longer keep up. That's great. As you're coming in, feel free to just let us know where you are joining us from today. I can already see we have got coast-to-coast representation. Fantastic. And there we go. We've got people already tuning in internationally. Anne-Marie from Zambia. Fantastic. Thank you, everyone, for joining us today. We will leave one more minute to allow folks to come in. Very excited to have everybody here today. So again, if you are just entering the webinar, please feel free to drop into the chat where you are joining us from today. This is wonderful. Again, we're seeing people from all corners of the country, internationally as well. We are going to begin our webinar. We are going to record this so that people can be able to view it on demand later. But we will officially get started. So hello, everyone, and welcome. We are so glad you've joined us today for our webinar, How to Optimize the Use of Manipulatives in Your IM K-5 Math Instruction, Lessons, Centers, and Managing Materials. This webinar is brought to you in collaboration between hand2mind and Illustrative Mathematics, and we're excited to dig into how manipulatives can be used most effectively to support deep conceptual understanding in your math classrooms. So whether you're just getting started with IM Math or looking to fine-tune your use of manipulatives, today's session is designed to offer both big picture insights and practical strategies that you can take straight to your classroom. Our contributors today will be the following wonderful people, each of whom brings a unique perspective and a treasure trove of personal experience in teaching IM, facilitating professional learning with illustrative math, and thousands of hours of classroom time combined. My name is Ryan Moore, Director of Client Experience here at Illustrative Mathematics, and I have the pleasure of serving as today's host for the webinar. We'll be joined today by Toka Hussain and Hannah Herbert from IM, and Brittany Gehrig from hand2mind. Toka Hussain is a PK-6 Senior Content Specialist at Illustrative Mathematics. She holds a BA in Childhood Education and Psychology and earned an MSED in Elementary Math Specialist program at Hunter College. She served as a math content specialist with a focus in content development and assessment. Her journey in education also includes serving as a New York City public school teacher, teaching math and science at the elementary level. Hannah Herbert is a PK-6 content specialist here at Illustrative Mathematics. She holds a BA and an MA in early childhood education and has over a decade of teaching experience in early childhood and elementary classrooms in Chicago and New Orleans. She has also served as an elementary curriculum development manager and an early childhood pedagogical coach. Brittany Gehrig is the senior manager of content at hand2mind with over 25 years of experience in education and professional development. Brittany is passionate about helping students and teachers build mathematical understanding through meaningful relationships in math. You will also see Christine Papazis providing ASL interpretation for today. We have a number of folks from IM and hand2mind as well behind the scenes to help us with your questions and answers. Before we dive in, I want to take a quick moment to show you how to engage with us through today's session. If you'd like to turn captions on or off, you can use the Show Captions feature to view subtitles if that's helpful. Feel free to use the chat box to say hello, connect with other participants, or share any aha moments. But a quick note, if you have questions for our presenters, please don't put those in the chat. They might get missed. Instead, use the Q&A feature. You'll see that at the bottom of your screen, right here where the red arrow is pointing on the slide. That's the best place to drop your questions for our moderators and presenters. We'll do our best to answer as many questions as we can during the session or at the end. So we are excited to have you here, and we encourage you to participate. Here's a quick look at where we're headed in today's session. We'll start by exploring the purpose and power of using manipulatives in K-5 math instruction, why they matter, how they support student understanding, and what that looks like in an actual task from the IM curriculum. Next, we'll shift our focus to manipulatives in math centers. You'll see examples from both K2 and 3-5 classrooms and get a glimpse of additional tools that can help bring these routines to life. Finally, we'll wrap up by talking about how to manage it all, from organizing materials and setting up routines to practical tips that make using manipulatives doable and sustainable in your classroom. Each section will include examples, visuals, and time to reflect on what this can look like in your own setting. So let's jump in with our first stop on the journey. Why use manipulatives in the first place? And a reminder, if you have questions, please use that Q&A feature of Zoom to ask them. This will keep us organized and ensure we can get the most questions answered as possible. Use the chat for shoutouts.
Thank you, Ryan. As Ryan said, we are going to be exploring how we can use manipulatives within our K-5 instruction. Throughout this webinar, there will be opportunities for you to interact with an IM activity. In order to participate with the virtual manipulatives that we will provide for you, you will need to be logged in to a Google account. You're also welcome to use connecting cubes or base 10 blocks if you have those available, or just a pencil and paper, whichever you prefer. So let's get started on our first section. We will be exploring using manipulatives in IM K-5 math and diving deeper into what that looks like in IM lessons. Before we dive in, let's take a moment to align on what we mean by manipulatives. Manipulatives are physical objects that students can touch, move, and interact with to make sense of mathematical ideas. Some of the manipulatives that you'll see throughout today's session are shown here. Connecting cubes, two-color counters, and inch tiles. We're going to take a closer look at how these show up in our curriculum and how they're used to support student thinking. You might also notice a few other commonly used manipulatives like base 10 blocks, pattern blocks, and more. There are also some that we won't have time to touch on today, such as fraction tiles and strips. This is not an exhaustive list by any means, but it gives us a sense of the variety of manipulatives that students will engage with across different grade levels. Now, let's look at how manipulatives are represented in our curriculum itself. At the lesson level, you'll often see manipulatives listed in the preparation or materials section. At the activity level, materials are broken down by each activity, and you'll see a materials to gather callout specifying exactly what you need. Additionally, you might notice manipulatives mentioned in the access boxes. These are suggestions for how manipulatives can be used to support access for students with disabilities or other learning needs. Now we're going to highlight some of the key benefits of using manipulatives in our math classrooms. There are so many reasons to incorporate them, but today we are going to focus on 4 main ones. First, manipulatives support conceptual understanding. They help students move beyond memorizing procedures and really make sense of mathematical ideas in a hands-on way. Second, they promote problem solving and reasoning. When students can physically explore and test out their thinking, they begin to see relationships, make connections, and justify their ideas. Third, manipulatives increase engagement. They invite students to explore, talk, and stay active in their own learning process rather than just watching or listening. And finally, manipulatives support collaboration and multiple learning styles. They give students different entry points to the same concept, whether they learn best visually, kinesthetically, or through discussion with their peers. Throughout our time today, you'll see how these 4 benefits come to life across different grade levels and activities within IM. Manipulatives support conceptual understanding by making abstract math ideas concrete. They allow students to make connections across multiple representations and give them a tangible, physical way to make sense of an idea or a problem. For example, in grade 3, when students are introduced to the concept of area in Unit 2, they begin using inch tiles, which is what you see here. This hands-on experience really helps them form a clear definition of what area represents and how to find it. As the unit progresses, students move from using inch tiles to working with grids and then incomplete grids. Eventually, they're introduced to the area formula. Starting with the inch tiles provides that important bridge between the concrete and the abstract, helping students really understand where the formula comes from rather than just memorizing it. Before we move on, we would love to hear from you and get y'all engaged a little bit. We would love for you to take a moment and think about what are other topics where incorporating manipulatives supports conceptual understanding. We know that you guys are from a bunch of different grade levels, a bunch of different areas of the country and the world, and we would love for you to share some of your ideas in the chat with us now. Oh, wow. Y'all are on it. Fractions, definitely. Volume, length, subtraction, addition. That's awesome. As you guys can see, you're really hitting a lot of the things we're going to be talking about today and how they can be useful, those same manipulatives across multiple grade levels. We can go ahead and move on to our next slide. Manipulatives also support problem solving and reasoning. They give students the chance to try out different ideas and test multiple solutions. Oftentimes, there is more than one way to approach a problem, and manipulatives make that visible. They also make our students' thinking tangible. We can actually see how they are reasoning through a problem. For example, in grade 1, Unit 2, Section C, students use connecting cubes to make sense of a comparative word problem. By modeling the situation with connecting cubes, they can visualize the quantities, compare them directly, and reason through what operations make sense. Using manipulatives in this way helps students connect math to real-world contexts, while also strengthening their problem-solving and reasoning skills, both of which are critical for developing a deep understanding of mathematics. Manipulatives also support engagement, collaboration, and multiple learning styles in the classroom. They encourage active and meaningful engagement by getting students physically involved with the math. Instead of just listening or watching, students are doing the math. They're actually building and sorting and comparing and exploring ideas all for themselves. For example, when kindergartners use pattern blocks to create designs, they're actively making sense of shapes and spatial relationships in a hands-on way. Manipulatives can also promote collaboration. When students work together with shared materials, they just naturally begin to talk about their thinking, explain their reasoning, and compare strategies. Those conversations deepen the understanding for everyone in the group. Manipulatives can also be a powerful tool for differentiation and supporting multiple learning styles. Manipulatives offer an entry point for every learner, whether they need a concrete scaffold to build understanding or they learn best visually or kinesthetically. This is often where you'll see those connections to our access boxes in our curriculum. These often highlight how manipulatives can remove barriers and make math more accessible for students with disabilities or other learning needs.
We wanted to take some time to look at an activity that strategically uses manipulatives to support student understanding. We're going to focus on Activity 1 from Grade 2, Unit 2, Lesson 2. In this unit, students add and subtract within 100 using strategies based on place value, properties of operations, and the relationship between addition and subtraction. They then use what they know to solve story problems. In this lesson, students add or subtract within 100 without composing or decomposing a 10, and they share the ways they find unknown add-ins. This activity uses connecting cubes and base 10 blocks. From the base 10 blocks, we're focusing on using units and rods, which are the ones and tens blocks. As we explore, think about how the use of manipulatives supports student understanding related to the work of this unit, section, and lesson, and how it connects to the strategies listed. So for the first part of this activity, each group of students would have some connecting cubes and some base 10 blocks. The teacher asked students to think about what is the same and what is different about these tools. Looking at the pictures and your knowledge of your students and these tools, what are some sample responses your students might have to this question? Feel free to put your responses in the chat. Yeah, so we see that both of them are cubes, one of them are the same color, one breaks apart. Great. A couple of other responses that we wanted to highlight was that both are cubes or towers of cubes. The connecting cubes are in towers of 10 and single cubes, and some are in towers of different sizes. The blocks are only in tens and ones, and the blocks and tens do not come apart. Next, we're going to dive into the second part of this activity, where students can use these tools to find the number that makes this equation true. We're going to take a few minutes to engage in this task. Like Hannah said earlier, feel free to use physical connecting cubes or base 10 blocks if you have them close by, or a pencil and paper if you prefer. We'll also be providing a digital option. We're going to drop a link in the chat shortly. Please click on the link to make your own copy. This will open a new window. You will need to be logged into a Google account to access these slides. So once you're in, you'll zoom out large enough to see the tools on the slide as shown in the image. So it was zoomed out to 118% for my screen, but the number might be different for your screen. Click on one tool at a time and then drag that tool to the slide to solve. You can choose to use either the base 10 blocks or the connecting cubes. There should be enough of each tool to solve this problem, but if you need to make more of a tool, click on it, copy, and then paste. You can also add text, numbers, or shapes to show your thinking. Feel free to also use the physical cubes or blocks if you have them close by, or draw them out on a piece of paper if you prefer. So please make a copy of these slides by selecting the Make a Copy button. We also just want to add that these slides were put together for the webinar. These tools are not available in lesson slides or on Access IM. We're going to take 3 minutes to work on this. If you have some extra time once you're done, feel free to explain your strategy in the chat. I set a 3-minute timer. We have about 2 minutes left, and just a reminder that if you have some extra time, you could put your strategies in the chat. We have about a minute left. And we're going to take about 30 more seconds. I'm seeing a lot of really great strategies in the chat. Thank you for engaging in that task with us. Whether you chose to use the virtual manipulatives or physical ones, we hope you got a chance to see how they support sense making in this activity. We wanted to take a chance to highlight a couple of the strategies that we might see students use, and we also saw a lot of these strategies mentioned in the chat. So in the first strategy, students use connecting cubes to show 41. They count on by 10 to 81 while adding a tower of 10. So 41, 51, 61, 71, and 81. They count by 1 to 84 while adding single cubes. So 81, 82, 83, and 84. Last, they count the number of towers of 10 and single cubes they added to find the unknown addend, which is 4 10s and 3 1s for a total of 43. Another strategy students might use is solving the problem with base 10 blocks. So this student, similar to our last one, starts with 41. Then they add 10s until they see there are 8 10s. So 5 10s, 6 10s, 7 10s, and 8 10s. Then they add 1s until they see there are 4 1s. So 2, 3, and 4. Lastly, they count the number of 10s and 1s they added to find the unknown addend. So again, we have 43. And the last strategy that we'll highlight shows a student using base 10 blocks to solve. This student starts with showing 84. Then they remove 4 10s and 1 1 and count the number of 10s and 1s that are left. These three strategies showed students using different tools and different methods to reach the same solution. The connecting cubes and blocks added a visual component, providing a concrete way to make sense of and reason about this problem. So we're going to return to that question from earlier of how did the tools support the work of this activity? The use of both connecting cubes and base 10 blocks in this activity supports student understanding of the base 10 system, especially in relation to thinking about place value when adding and subtracting. These tools provided a concrete way to add and subtract, and they provide a visual representation for place value in this equation. The use of these tools encourage students to make connections between addition and subtraction, which we especially saw in the last student response, where the student started with the sum and subtracted 41 to find the missing addend. In this specific activity, students did not compose and decompose, but their work with these tools in this lesson will support their work with composing and decomposing in this unit. Which is a great segue to our next question of how does the use of manipulatives in this activity and lesson support future work? In the following lesson, students use these tools to solve addition and subtraction word problems. These tools provide a concrete way to make sense of problems and reason about them. These tools, especially the cube towers and base 10 rods, also support future work with place value, including work with number lines, especially when it comes to jumping by tens when adding and subtracting on number lines in grade 2, unit 4, and beyond. The ideas built around tens and ones build a foundation for future work with place value relationships through 1 million, and supports work with the 4 operations with larger place values, which happens in grades 3, 4, and 5.
Let me turn my camera on. Awesome. In the activity that we just looked at, we saw how students use manipulatives to make sense of a concept, and we talked a bit about how their use of those manipulatives will continue to build over time. As students move through the year, their work with manipulatives evolves. Across grades, we can see a clear progression of representations. This chart on your screen highlights a few examples of those progressions across different topics like measurement, number and operations in base 10, and fractions. We won't take the time to read through every example here today, but what's important to notice is the structure. One of the key design features across IM courses is this intentional progression of representations, and manipulatives are a big part of that design. This connects back to what we discussed earlier about supporting conceptual understanding and helping students bridge from hands-on learning to more formal math reasoning. To make this idea more concrete, we're going to take a deeper look at the number and operations in base 10 progression and connect it back to the task that we just explored. This will give us a closer look at how manipulatives support understanding within this progression over time. In kindergarten and first grade, students begin by working with two-color counters as they explore counting objects and understanding the number sequence. This hands-on work lays the foundation for understanding quantity and one-to-one correspondence. Next, students begin arranging those counters into 5 frames and 10 frames. These visual structures help them recognize patterns and begin to make sense of our base 10 system, seeing 10 as a benchmark for understanding numbers. As students move into the next stage, they work with connecting cubes and cube towers of 10. These manipulatives continue to support their understanding of base 10 and also help them compose and decompose numbers, breaking numbers apart and putting them back together in flexible ways. From there, students transition to using base 10 blocks, which make place value relationships more explicit. They can see and feel the difference between ones, tens, and hundreds, and this deepens their understanding of how numbers are structured. Finally, as students begin working with larger place values, they move toward more abstract representations like base 10 diagrams. At this stage, they've internalized the structure of the base 10 system and can reason about it symbolically without always needing the physical manipulatives. This progression from counters to cubes to base 10 blocks to diagrams really illustrates how manipulatives can help move students from concrete to abstract thinking in a purposeful, supported way. Now that we've had a chance to explore how manipulatives show up within an activity and a lesson, we are going to take that a step further and look how manipulatives come into play in our centers. In IM centers, students have opportunities to explore concepts more independently and apply what they have learned in flexible, hands-on ways. Each center has multiple stages that students progress through over the span of a school year or multiple grades. We'll take a look at how manipulatives support that exploration and how the design of our centers continues to build on the same concrete to abstract progression that we've been talking about. The first center that we would like to highlight is called Shake and Spill, which is used across kindergarten through second grade. This center uses two-color counters as the main manipulative, and it is a great example of how the same tool can support learning across multiple grade levels. In kindergarten, students begin in stages 1 and 2, where they use the counters to explore one-to-one correspondence, the counting sequence, and visual representations of numbers. As students move into stage 3, which is typically in first grade, they're still using the same two-color counters, but now they're using them in a new way to represent and create expressions and equations. Then, in stages 4 and 5, which is usually in second grade, students use the counters to model number decomposition, breaking numbers apart, putting them back together to understand the part-whole relationship. So across these stages, the same manipulative, two-color counters, supports a progression of skills. Students build on familiar tools to make new connections across topics and deepen their understanding over time. Another center that we would like to highlight is called Can You Build It?, which is used in grades 3 through 5. In this stage of the center, students use inch tiles to make sense of area. In this specific stage, they are working in pairs to build rectangles, describe them to their partner, who then tries to build the same shape. They then discuss how their rectangles are similar and different. As they move up through the grades, this work progresses into using cubes to make sense of volume, helping students extend their understanding from area in 2 dimensions to volume in 3 dimensions. This center is a great example of how manipulatives can support conceptual understanding. Students use concrete objects like tiles and cubes to make sense of abstract ideas such as square units and cubic units. It also ties back to problem solving and reasoning. Students are challenged to test their ideas, build models, and reason about the relationship between length, area, and volume, all through hands-on exploration. So again, we see that progression. Manipulatives start by grounding students' understanding in the concrete and then help them make connections as they move toward more abstract reasoning. Several IM centers also include additional materials, things like game boards, recording sheets, or playing cards. These tools elevate the way that students use manipulatives to solve problems. Sometimes they guide the math thinking, and other times they act as the manipulatives themselves, helping students represent, organize, or extend their ideas. You can see a few examples here on the slide, centers like pattern blocks, 5-in-a-row multiplication, math fingers, and tic-tac-round. We won't go into detail on each of these today, but the key idea here is that the materials add layers of structure and engagement. They give students more ways to model their thinking, make decisions, and communicate their reasoning, all while keeping the work hands-on and interactive. At this time, we would like to turn it over to Brittany from Hand2mind to share some information about the type of manipulative kits that they offer.
Yes, thank you very much. As an IM certified partner, hand2mind offers classroom tested kits that reduce prep, increase engagement, and help educators bring problem-based learning to life. We want to talk about a couple of different kits that we have that you can see on the screen right now, which are our essential and deluxe manipulative kits. Each one of these kits has enough materials for 30 students. In our essential kit, it includes the core manipulatives that are aligned for IM Math 360 and the first edition. And our deluxe kits add extra supplies to streamline prep and extend activities. The whole idea here is to help students visualize and reason through math concepts in real world context, just as you have already heard today with Toka. The next kits that we have available are, if you'll click, I believe we have one more. This are our center kits. And so those centers that we just looked at, we have those at hand2mind. They are aligned to the grade levels in the units, and they include all the materials for up to 5 groups. The whole idea here is to help teachers not have to take their time to prep. So it eliminates all the prep and the printing. They're ready to go. And it really helps to support the repeated use and varied outcomes for reinforcing those concepts.
Thank you, Brittany. In our last section, we're going to explore managing materials, and we're going to talk about some simple things to introduce into your classroom or to continue using in your classroom that might make using manipulatives just a bit more manageable. We're going to start off with a video from a kindergarten classroom. This is Unit 7, Lesson 1 on building shapes. This clip focuses on the teacher introducing Activity 3, which is center choice time. Students choose from activities that offer practice with number and shape concepts. While we watch this clip, we're going to do a notice and wonder. So as you watch the video, feel free to put any noticings and wonderings into the chat, specifically with the lens of any teacher moves that support the use of manipulatives in her class.
We did. We're going to move into our center time and practice row and the skills that we have learned. Here are our centers. Oh, I saw and I heard you were so excited. I heard Ryan say geo blocks again. At table 1 is going to be geo blocks. Remember, I will put the pictures out so that you can try to build one of the pictures, okay? Ooh. Here we go. Table 1.
Favorite center.
Table 1. It's your favorite center? Okay, grab and count. Eyes on, please. Grab and count will be at table 2. Please remember, this is an estimation practice of counting and guessing, okay? You're not supposed to count the blocks until you've written your guess down, all right? You're supposed to estimate first, then you count, your partner counts, write the number, table 2. Table 3 is find the pair. You work with a partner to find a pair that equals what? Find a pair that equals what? 10, yes. And then write your expression to match, table 3. Now, Rowan, I'm pulling the center out just for you because I know it's your favorite.
Oh, that's my favorite too.
What's this center?
That's my favorite.
It is.
Yeah,
Find the
I know
expression,
that.
right? Find the expression helps us practice our abacus addition and subtraction skills. So table 4. And then table 5 today, we are going to do our make or break, where you roll the dice on the teen number and then you have to build it. Crystal, what if I rolled on the 16? Which ones would you pick? A 10 and a 6. So she'd put her counter on the 10. She'd put her counter on the 6. That Miss Mama can't see. Oh, here's one. The 10 and the 6. And then you write the expression that matches. Okay? Table 5. All right, quiet think time. And thank you, materials managers. Ayub, table. Bryson's thinking right now what center he wants to go to first. I see him thinking about it. When I release you to go to your center, what kind of feet do you have? Walking feet. If there's no chairs at your table, you go to center choice number 2, okay? Walking feet. I will bring markers to you if you need them. Okay, thank you. Because Millie, what center did you go to? Set an alarm for 8 minutes. All right, did you split your 5 cards and 5 cards?
Yes.
Crystal, give Dimitri 5 cards.
5. 1. 5 for me. Okay. 2. 1 and 5.
Did you write your expression? Nice job.
And the last one. I love this game.
You love this game? Why do you love this game?
Because it's so fun.
What does it help you practice?
How to make 10.
How to make 10. Good job.
This is so fun. Yeah. Okay, ready?
All right, bud.
We hope you enjoyed that clip. In this clip, we saw the teacher prepare her class for center time, and there were a couple of different things that we wanted to highlight that the teacher did to make center time go more smoothly in her class. A lot of these were called out in the chat. So one important thing is that she incorporated students into the process. We saw there were a few students lined up in front of her that were ready to bring the materials to the correct table, and she referred to them as the material managers. At the end of center's time, they also helped collect and bring back the materials. It's a fun and easy way to incorporate students into the process while also taking a little of the load off of the teacher, and the students absolutely love it. They were excited and they take their job very seriously. We also saw that the teacher had easy access to materials, everything laid out right next to her desk, and there was also a center where she pulled out a bin, which only took her a few seconds to locate and pull out. The bins were either clear or labeled, so it's easy to see exactly what's in it, which makes it quick and smooth to grab and go pretty quickly. We also saw that for the centers, the teacher had them organized in large Ziploc bags with most of the materials for the centers inside. She quickly pulled them, and it was easy to access the exact centers that she needed and pass it off to students to put at the table. We also saw that the students were familiar with the materials, and the teacher just gave a quick summary to refresh for every single center. Some of the students even happily shared their favorites. Towards the end of the clip, when the students were working in centers, we saw some students writing on the center sheets with dry erase markers. Another helpful tip is making sure the sheets are laminated or putting them into binder sleeves to make them dry erase, which makes it easy to reuse the center. During a different activity, all students were working with pattern blocks. The teacher had all the pattern blocks portioned out for each pair of students. She used plastic pencil cases for this, but Ziploc bags also work. It made it easy for every pair of students to grab what they needed, and it's also helpful to have accessible areas for students to grab and go to get the materials that they need for an activity or center.
Part of being successful with manipulatives, especially during centers time, is having clear and consistent procedures and routines for your students. There are several ways that teachers can set their students up for success, and we're going to highlight just a few of those here today. First, always give your students time to play with and explore each manipulative before you introduce it as a math tool. This helps them get curiosity out of the way so they can focus on the math when it's time to. Next, take the time to define and model expectations for each center. Show the students what the activity looks like from start to finish, how they carry it to their table, how they set it up, how to use the materials, and how to clean it up afterwards. It's also really helpful to explain the purpose of each manipulative, why we're using it, and how it supports our math learning, so students start to see them as tools for thinking instead of toys. You might also consider including visuals of how each center should look when it's in its container and when it's set up ready to be played. That way, even when a teacher isn't nearby, students can use those pictures to double check their setup before beginning or to make sure that everything is put away correctly for the next group. Throughout the year, keeping the same routines for center time helps everything run smoothly. This might include a consistent signal to start and end centers, like a call and response phrase, a short song, or a classroom timer. Give students a clear and consistent amount of time to pack up and transition, and if possible, assign specific roles, like a materials manager, whose job it is to make sure everything gets returned to the right place. Simple and predictable routines like these help students take ownership of their learning and keep the focus on meaningful math exploration. We know that manipulatives are physical objects that can be touched, moved, and manipulated. We've looked at several examples today that are commonly used in K-5 classrooms, in IM, and included in the hand2mind kits. However, a manipulative does not have to be something that's specifically called out in a curriculum or something that comes from a kit. We would love for you to take a minute to think about other manipulatives that you use in your classrooms, maybe ones that are not officially labeled manipulatives, and share some of those ideas in the chat with us now. Oh, mini erasers that match the seasons. I love that idea. I used to do that as well. Rack and racks, paper clips, popsicle sticks, straws, magnet tiles, little glass rocks. Those are so fun. Post-it notes, stickers. You guys are totally right. Some examples that we have used ourselves and that we have seen teachers like you guys use are loose parts like pom-poms and buttons, or natural materials such as rocks, sticks, and shells. Even things like playing cards and poppets can serve as manipulatives depending on how they're being used in the classroom. These kinds of everyday materials are a great way to connect math to student interests and give them ownership over their learning process. You can even invite students to help choose or collect the manipulatives that they'll use in a center, or even invite them to bring something special from home. That sense of involvement often leads to deeper engagement and creativity. We have covered a lot of information so far today from both IM and hand2mind. And to finish out our time together, I would like to pass it back to Ryan for a little bit of Q&A.
Fantastic. Before we move into questions, I want to just take a moment to thank you all. Give a big thank you to our presenters for such a thoughtful and engaging presentation with some fantastic insights that took me right back to my time teaching IM in a 5th and 6th grade classroom. It's just always so helpful to see these practical examples and real classroom strategies brought to life. We have been getting some questions put into the Q&A. If you haven't done so already, this is a great time to drop your questions into that Q&A box. Again, you'll find that at the bottom of the screen. That's the best place to make sure that it is seen by our team. We've already had some great ones come in, and so I'm going to ask some of our presenters to come off mute to answer some of those questions. I think, Toka, you have the first one you wanted to respond to?
Yeah, sure. So the first question is, are there directions available of how we could make a Google slide like the one we just used, where we can drag tens and ones onto the slide for our students to use in our classroom? So just some quick tips for doing this type of activity, and it looks a lot it's a lot easier than it looks. Basically, you just you could screenshot or insert images into the slide, make as many copies of each tool that you'd like for students to interact with, and then when you share the Google Slides, you would just need to adjust it to anything after edit in the link would just be copy, and then you could share out, it'll force a copy, and students can easily interact with any materials in those slides.
That's fantastic. That was a really great, nifty virtual setup. So I think, Toka, do you have one more? I can't remember this one about progressions.
I can touch on that. The other question was, do you have progressions for the use of materials for the other domains like you showed for the numbers and operations in base 10? So the chart that we highlighted is also included in our course guide. You could find it under purposeful representations, this under the key structures in the course guide for K through 5. So this helps explain how the representations connect within and across grades. And additionally, another helpful resource might be unit, section, and lesson narratives. They're helpful for understanding the representations and materials included in those specific components. So those for that lesson, for that section, and for that unit.
Fantastic. Thank you, Toka. One that just came in, a simple question that I know I can answer, which is, will this recording be shared to reference? Yes. This webinar, along with many of our past webinars and some ones that were also recorded on demand, will be available on our IM Experience page. When we get to the final closing of this, I'll show a link to where you will be able to find that as well, so that you can share it with other colleagues if they didn't get a chance to tune in today. I am checking our Q&A. Let me know, presenters, Toka, Hannah, Brittany, or Audrey, were there any questions that people were going to speak to here that I may have missed? If any other ones come in, we might be able to come right back to it, but let me get to some of those things that I was letting people know about where you can be able to find these resources. So as we wrap up, I want to thank you all for spending your time with us today. Whether you're just beginning your journey with IM or you're already deep into implementation, we hope that today gave you some ideas and tools to support your work. So before we go, we want to make sure you know about some free resources that are available to you. If you haven't already, you can explore the full version of our IM V360 curriculum at accessim.org. The QR code that is up on the screen will take you there. If you haven't registered for an open access account yet, you'll be prompted to verify your identity as an educator. This simply helps us ensure that students aren't accessing any teacher materials. But a pro tip here, if you have a colleague who is already verified, you can ask them to invite you directly to skip the ID verification step. When you get into the accessim.org site, there's a spot at the bottom that says invite an educator. Of course, if you run into any issues, our client engagement team is always there to help, and there's a button you can click to send a message to our client engagement team. If you would like to stay in the loop about future webinars, new resource and updates, we invite you to join our mailing list, which you can see here in the chat. And as I mentioned, in addition to webinars like this one, our IM experience is all about connecting educators through meaningful, ongoing learning opportunities. And that includes our blog, our podcast, case studies, conference sessions, and other interactive resources that help bring the IM mission to life. So our IM experience page is what brings all of these touch points together. So here is the link for IM experience. I will pause right here because actually I think we have a few more questions that we can that just came in before we get into our resource hub. Hannah, were you gonna, I can't remember if it was Hannah or Toka who's gonna take, we have a couple more that came in right before our closing. I'll go through these while we take a moment to check out those questions. So if you haven't been to our website recently, there's a ton of free content waiting for you. There are downloadable ebooks, again, the on-demand webinars, classroom-ready teaching resources, and our blog. You can connect directly again with our IM client engagement team to schedule a call to have a more in-depth conversation and a thought partner about your school's districts or needs. And also, we have also launched IM Math Lab. It's a new professional learning experience where educators can observe real classrooms, see student thinking in action, and reflect on what makes math a learning journey that is joyful and effective. So follow the links below to sign up and stay informed about these IM opportunities. We're going to see a whole bunch that are entering the chat now. So our resource hub, our blog, webinars on demand, both this one and previous ones, our implementation reflection tool, and a place to sign up to learn a little bit more about Math Lab. If you did have a question, you can pop it into the chat. We will do our best to get these out in an email that might go out after the end of the webinar if there were some frequently asked questions that a lot of people came to us with. But with that, I want to say thank you so much for joining us today. We hope you are walking away with some fresh ideas and practical strategies for bringing manipulatives to life in your IM classroom. We would love to hear your thoughts. And so we have a very short survey that you can take that we will put into the chat right now. Just take a few moments right here to share your thoughts on today's webinar. A big thank you to our wonderful partners at hand2mind for their collaboration and shared commitment to supporting math educators. Thank you so much for joining us today. So once again, whether you are brand new to IM or further along in your journey, we are honored to be doing this work with you. We hope to see you at a future webinar and event. And until then, keep empowering your students to know, use, and enjoy mathematics. Take care, everyone.